rotational motion la ஒரு conceptual sum பார்க்கலாம் பாருங்க. A football of radius r is kept on a pole of radius r. This r is very less than capital R. Capital R is the radius of the football. Small r is known as the radius of the pole. Made on a plank kept horizontally. One end of the plank is now lifted so that it gets tilted, making an angle theta from the horizontal as shown in the figure below. The maximum value of theta so that the football does not start rolling down the plank satisfies figure is schematic and not drawn to scale. Here given that this is the one plank. In this plank we have made a hole. This whole radius is r, so that this diameter is 2r. Next this ball is kept. This ball radius is r. Now what we are doing in the sense, this plank we are tilting from the horizontal so that it makes angle theta with horizontal. As theta is increases at certain value of angle theta, this ball ready to roll down. So just before ready to roll down, what is the angle theta? The maximum value of angle theta is given. For that angle theta and the radius of the hole and the radius of the ball relation is given. Which option of correct we have to find. So now let us take here what are the forces acting here in the sense. Here three forces acting. One is weight of the ball. This is the weight of the ball, that is vertically downward mg. And what are the other forces acting here in the sense here? Contact point. At this point contact point, and here one contact point is there. In these two contact points, this contact point let us take point A, this contact point let us take point A, this B, this A. At point A let us take normal reaction N1 is acting, at point B let us take normal reaction N2 is acting. Now as theta is increased, when ball ready to roll, as it ready to roll, so that at point B this ball just lifted. As this ball just lifted at point B, so that there will not be any contact at point B between plank and this ball, so that this N2 will be, we assume to be 0. N2 we are assuming to be 0. Now what are the other two forces are acting means, one is mg force is acting, another one is normal reaction is acting. Now it ready to roll down is there, that means as it is ready to roll down, it is equilibrium in both translatory as well as rotational. It is translational as well as rotational equilibrium. Rotational equilibrium. In the case of translational equilibrium, net force should be 0. What are the two forces acting in the sense? Mg is acting, another one is normal reaction is acting. That means we have to take normal reaction plus mg is equal to 0 we have to take. So that N1 is equal to minus mg. That means mg is downward acting, that N1 should be acting upward. And another thing, it is in rotational equilibrium. Rotational equilibrium means net torque should be 0. Total torque should be 0. So total torque should be 0 means here only two forces are acting. That means the two forces are acting in opposite direction. If two forces are acting opposite direction, then total torque 0. Then these two forces must act in the same line. Must act in the same line. That means mg it is acting downward means in the same line only n also should be acting. Normal reaction n1 also should be acting. Because total torque is 0, rotational equilibrium. So that n1 and mg are acting on same line we are taking. So by considering this, let us redraw this diagram. Now we take ball. This is the ball we fix here. Let us consider here mg acting downward. This mg is acting downward. In the same line only should act n also. Normal reaction also should be acting same line. N also should be acting same line. In this line, n should be acting. So n and mg almost center we assume. This center mg is acting in this direction we have to assume. So now this is the point. Let us take this is the point we take as a some P like that. We let us take this is the point we take A. This is the point A we take. This point center of this sphere as a O we are taking. Now listen here. Now this length is we know that this B to A is this is the point B. This is the point B. B to A we know this 2R. That means this P to A, this length P to A, this length is R. And O to A, this O to A is capital R, radius of the ball. And from O to P, if we draw line, this line will be perpendicular to R. This diagram, let me draw again. Now we take mg is acting from this point, from center, and normal reaction is acting. Normal reaction acting in this direction. So mg is acting downward. Normal reaction n1 is acting upward. This is the center of the ball. So this is the point O, and let us take. This is the 2R. This is the 2R. In center point, let us take as a P. This is the point B. A to B is 2R. And P to A is R. P to A is R. Next, from O, we draw perpendicular line to P. Because P is midpoint, AB is the chord. From O, we have drawn perpendicular. Any line drawn from center to midpoint of the chord, it will be perpendicular. This O to A is capital R. Now let us take triangle. This OPA. This is the point O. This is the point P. This point is A. Now this angle P is 90 degree. PA is R, and OA is capital R. Now by extending this mg, this angle we know that theta, and this angle will be 90 minus theta. So that this angle A will be 90 minus theta. This angle A is 90 minus theta. Hence, this angle O is theta. In the right angle triangle, angle P is 90 degrees. So capital R is hypotenuse. Opposite angle theta is this side smaller. Hence, we take sin theta is equal to opposite by hypotenuse. So opposite side is smaller, hypotenuse is capital R. So answer for this question is small r by capital R is the correct answer.